Okay, this is 2.4, transformations of parent functions. And hopefully most of this will look familiar to you, and if it doesn't, then this will be a good review for you. So it says, given the graph of y equals f of x, describe the effects of each transformation. So when it is inside the parentheses, remember it's always opposite of what you think it's going to be. So when it's plus a, you're going to go left a units. When it's minus a, you're going to go right a units. So this would be a horizontal shift, and that's going to be a units. When it's outside the parentheses, you're saying your function adds a or your function subtracts a. When you're at a, this is going to be up a units, and this is going to be down a units. So this is your vertical shift. We've got a times our function, and we've got a times x. So the first one is going to be our vertical, and you can have a compression or a stretch. And here's the difference. When you have a stretch, your a value is going to be greater than 1. And I like to go ahead and take the absolute value of a. So a value is greater than 1, and you compress, or some people say shrink. Same thing. Go ahead and take the absolute value of a, and that's going to be less than 1. When you do a times x, this is where it's a little bit confusing. A is inside the parentheses. It's still going to be like above. This is horizontal. And you still have a stretch or a compression, or you can call your compression a shrink. Since it's inside the parentheses, you need to think opposite of what it is. I still want you to do an absolute value, but the stretch is going to be less than 1 this time, and the compression of a is going to be, absolute value of a is going to be greater than 1. All right, when you have a negative outside, this is like saying negative y, and inside the parentheses, this is like saying negative x. So outside, so negative y, this is going to be a vertical reflection. And so this would be the opposite, and this would be a horizontal reflection. And the absolute values. So I know you were taught this last year, but I don't want you to get confused. I'm gonna, let's see. Let's do it this way. So I'm gonna let you kind of write down what you think of this. So this is like having the absolute value of y. So all my values of y, no matter what, should be positive. Okay. Let's draw, and do your best to draw this graph so you can see what graph I'm looking at. Here's my graph. Here's my given f of x. If I want all my values, any value of y to be positive, because that's what the absolute value means, then this is what my new graph would look like. So this value, let's start over here. This value of y is already positive, so this is my new graph. Let's see, new graph is going to be red. So this graph is going to stay, this graph is going to stay, and this graph is going to stay. This down here is all negative y's, because this is your x and this is your y value, right? So all of these are negative, so I'm going to flip them up. So these all stay, so I'm going to flip this up and do my best to graph this. So this is going to go up, this connects here, and then that connects. So this is my new graph, taking the absolute value of y. Okay, I'm going to do the same thing for my absolute value of x. Okay, again, I'm going to draw my new graph in red. So on number 10, I'm taking the absolute value of x. So how is this going to be different than number 9 that's taking the absolute value of y? So I want all my x values to be positive. How I like to think of this is basically throwing out any negative x's. So this x value is positive. This x value is already positive. This x value is already positive. So basically what my graph is going to look like is I'm going to repeat it over here. Made this one really big, sorry. If you can see this because I'm drawing over my words. You might want to take a minute, pause the video, and write down what you're doing and how to make your absolute value of y and absolute value of x. Also, when you're graphing, you always work from the inside out unless you have the absolute value of x. You always do that last. Okay, when graphing these, last year I know y'all listed your points in order to graph, but I'm not going to do it that way. I'm going to list it by my shifts. Remember, you work inside out. So my first one is going to be a shift, and this is going to be a horizontal shift. And it is going to be a stretch. So I'm going to list this, and then I'm going to go ahead and do it. So this first one, remember it's opposite, so I'm going to multiply by 2. So I'm going to take all my x values and multiply them by 2. So this would be here. This point goes here. My x value here stays, so let's go ahead and connect this. This x value stays here. This x value is going to come out because I'm stretching it. If you want to make this a point, it might make it easier. This is going to go out to 4. And then 3 goes out to 6. So you can go ahead and see the hump there. Okay, my next shift would be this vertical flip or reflection. So this, everything that's on my x-axis is going to stay. So flip everything over it. And go ahead and connect as you go. It's going to start getting really messy here. The nice thing about your pencils is you can erase everything that you are not using. And then this hump is going to change directions. And then I have one last step. That's going to be up 2. So my last one was the red, and I'm going to take everything and shift it up 2. So there's 2 and 2. This one's going to be up 2. And it's easy if you go ahead and connect as you go. And again, if you have your pencil and this looks way too messy for you, erase as you go. I just can't do that. So this is my last one, this black one. And if you would like to do it like you did last year by writing down your points, you're more than welcome to do so. Okay, for number 2, you only have, looks like you only have 2 steps. So my first step would be to shift left 2 units. So take each point, go to the left. Be easy to connect them as you go. I'm going to add a point here to make it a little bit easier. And my second step, or my last step, is to take the absolute value, and this is right here. So this is the absolute value of y. Absolute value always goes last. Okay, if you need to flip back and look to see what you do with absolute value, on my absolute value of y's, remember, all your y values need to be positive. So this is going to stay, this stays, this stays. This down here is going to reflect up or become positive. So it's going to go here and connect with that. So I got rid of this blue one down here and brought it up. All right, let's try number 3. So my first step here is going to be a horizontal reflection. You're more than welcome to, at any time, pause this or move forward and see if you can do this without my help. So horizontal reflection means that all these points are going to be over here and vice versa. So the 3 is going to be over here This is here. These are connected. And this is over here. So it is backwards. Next step would be times 2. And remember this 2, the absolute value of the 2 on the outside is going to make this a vertical stretch. So this is going to get tall. So everything times 2. And I'm not really doing this in an order. I'm just kind of... So this one's going to stay here. And this is going to just be a tall hump. All right. It gets really messy when there's a bunch on there. So let's now go down 1 unit. Just trying to make this as dark as possible for you. The black is my new one. There we go. Okay, for our last problem. Remember, absolute value goes last. So our first step, in fact, I'm going to combine these, but if it confuses you, you can do it in 2 steps. I'm going to combine both of these as 1. So I'm going to go right 2 and up 1 as 1 step. Y'all are smart enough to do 2 steps. Okay, I'm now going to do the absolute value of x. Remember, absolute value always goes last. For your absolute value, remember all of your positive x values are going to stay. Okay. And then on the left side, those go away, and we're going to repeat the right side to the left side. And you should have a replica on the left side exactly the same on the right side.